everybody. Just to welcome you to White High School, and we're very kind of flattered and honoured that we could host this event and this lecture. And we've had, Iain was kind enough to present the lecture to our senior pupils today. We've got 6 years who are involved in national or higher geography and the sciences as well, so they thought it was fantastic and did a great job, and a lot of really positive responses. And I think that's the thing, it's highlighting what's going on within the community and inspiring these pupils, I think, to be looking further afield and choosing careers as well. So it's just my position to talk and do the air steward bit, to say that there's a fire alarm that's not planned, so just find an exit and run. And good luck with that one. And you obviously you've access to staff toilets and the staff rooms as well, if they decide to have a comfort break at some point. Can I introduce now the Vice President of the Royal Society of Edinburgh, who I've only recently found out and met, is an ex-pupil of White High School, which is fantastic. So, yeah, very proud. Is there anybody from Gala? He's aware because he's in for a fight. So, but it's Sir David Wallace, the Vice President of the Royal Society of Edinburgh, and just in conversations, he had came up from Edinburgh University, then over, and I hope I'm not spoiling your introduction here, but moved over to Princeton in America, and then came back and worked in Loughborough, and now is based in Edinburgh. So we will actually be talking to Sir David to get him to come in and speak to the pupils, because I think that would be fantastic, because it's great to see pupils from the area be so successful and show how much they can be involved in the sciences further afield and come back to the area. So it's excellent. We're very kind of honoured to have Sir David here. So I'll hand you over to Sir David Wallace.
Thank you very much, and I'm really pleased to have my own welcome. I should say that I know that you're here to hear Professor Stewart, to hear Iain, and not to hear me, so I'm going to be very brief. But as far as I'm concerned, I just said I'm really, really proud and happy to be back in my old school. But the head has to be very careful. He should take a reference from Drummond High in Edinburgh, because I did give a talk there this afternoon, and if it's a bum reference, he shouldn't ask me. So first, about the Royal Society of Edinburgh. First thing I've got to say is that the title is misleading. Yeah? There's no connection with royalty, except that it gained its founding charter from King George III in 1783, and I just want to reassure you that this was before he became mad. The Royal Society of Edinburgh is Scotland's national academy. It's not just about Edinburgh, and of course that's why we're here in Scotland's National Academy. Its mission is to advance learning and useful knowledge, which is a great, succinct, simple objective to have. As far as the Christmas lecture is concerned, it's actually quite a long-standing activity, outstanding lecturers, great tradition, and this year is absolutely no exception. I should mention as well that you will discover more as you go into next year. There's going to be a program in the borders, which this year will be a program of what's called RSE AT, with the at symbol, with a lot of activities in the various border towns. So keep your eyes and ears open for publicity in the media about that. I was asked to say this, and it's really crass, but most of this program is largely externally funded, and we have raised £21,000. But if there is anyone here who would like to get more closely engaged with the Royal Society of Edinburgh, just don't feel embarrassed that I'm saying you have the opportunity to talk to me later. Anyway, now on to the main attraction for tonight, and that's Iain himself. He's a Professor of Geoscience Communication at Plymouth University in the UK. He's Scottish, as you'll hear. In fact, you probably already know that because you'll have seen him on television. And a man of many parents. He's a holder, in fact, when he was a child, of an equity card. Is that correct?
It is correct.
It is, yeah. Probably acted alongside very famous people as well, equally famous people. And he studied, then went on to study geography and geology at Strathclyde, and completed a PhD in earthquake geology at Bristol. Some very famous people. obviously. Now, you will all know him through his BBC programme. He's had some fantastic things. We're really lucky that Iain is with us tonight, and we can engage with this person and this expert personally in this subject. Some of his programmes, I've got them here: Earth, the Power of the Planet, The Climate Wars, How Earth Made Us, How to Grow a Planet, Volcano Live, and so it goes on. He's fronted a lot, haven't you, for BBC Horizon specials as well. I think I should give a plug, right? Your latest BBC series, Planet Oil, have I got that? A three-parter on the history of petroleum is going to air early in the coming year, February. Great. Lots of international awards: Royal Geographical Society, Geologists Association, Geological Society of London, and so it goes on. Another interesting Scottish connection is that Iain is president of the Royal Scottish Geographical Society, and a teaching connection is that he's president of the Earth Science Teachers Association. And he was in the Birthday Honours list. He, I think last year, got an MD. Can you imagine anyone better than Iain to talk to us about Meet the Frackers, a geological perspective on UK shale gas? Please welcome.
Thank you. I want to start with a sort of diversionary tactic. In early 1964, something dramatic happened. Something dramatic was conceived, actually. It wasn't me. I was conceived in that part of early 1964. I don't know the details, so to find out any more about it. My mum and dad are here, they may have some of the details. But the point was, what was conceived was the notion that the North Sea had economic potential in terms of particularly gas, which had been found in the northern part of Holland and St. George continued offshore, and possibly oil. And then if you go to later, by November 1964, when I was born, they were drilling for oil and gas. Didn't get any. It took a year later, in December of 1965, when the first well in the southern North Sea hit gas. That was the first real significant realisation that the UK had a domestic energy source and didn't have to rely on energy coming from its kind of colonies, if you like, the Middle East and various places. That euphoria was a little bit short-lived, because the drilling rig that had found that gas was called the Seagen, and on Boxing Day 1965, just a few weeks later, it collapsed into the waters of the North Sea, and 13 people were killed. But that was the start of essentially the North Sea industry, the oil industry. And so we were coming up to 50 years, which is why I just finished doing something on Planet Oil. So the reason I'd say this alongside me is that my life is the same length of time as the oil industry that's been going on. And what we see here, the map, is the kind of the fields, mainly gas fields, in the southern part in red, and then scattered up here are the oil fields through this main part. That has basically been producing the oil and gas that we have over the last, since the 70s, since the first big finds, the Brent in the 40s. Some of these giant fields. At one point, bigger fields were getting found in the North Sea than were getting found in Saudi Arabia. And you see this rise through essentially what my life, the time that I've been to see this kind of rise in the North Sea becoming a really important energy domain for this country. So we end with this. I am hydrocarbon man. You are hydrocarbon men and women. We've grown up with this energy, or I've grown up with this energy offshore, bringing oil and gas. But it's not just about energy. The clothes that I'm wearing, that polyester shirt, that's oil and gas. The plastic that we create, the modern world in terms of kind of plastics, that's oil and gas. The food we eat, we've had cereal for breakfast today. The gas, the fertilisers that created that allowed those cereals to grow, because nitrogen fertilizers are made from gas stock. The oil and gas that's coming out is infiltrating our world in ways that we can't even conceive. So really what I've got now at this point is that I am completely embedded in hydrocarbon. I and our society are largely addicted to this stuff because it's slowly crept into our world such that almost every part, if not every part of it, is actually steeped in this. So, it's not just, I want to kind of move across to gas, because I want to set some context and now kind of move on to Frank. It's not really gas. Many of you will probably find it's gas that heats your homes. 80% of the homes in the UK are heated by gas. But the main thing that kind of focuses attention is energy. And this really goes from the early 60s all the way through, and it shows that changeover that was very recognisable amongst many of us of coal, going from solid fuel, and then really by the time the 90s come in, there's a really dramatic switch over. It's the demise of the coal industry. The coal industry plummets. Why? Well, one of the reasons the coal industry plummets is because at the time it gets to the early 80s, when there's a big conflict with the National Union of Miners, the North Sea is providing lots of money and energy into the UK system, so that Thatcher can go up against the coal miners, knowing that she's got backup in terms of energy. She also commissions lots of nuclear power plants. But that really is a death. The demise of coal. The coal goes down, and then by the time we get to the late 90s, essentially gas is taken over from coal as the main energy supplier in the UK. So here's the story from the North Sea. What we see then is we see there's an extra rise. So just to get clear, this is all of the countries that, this is Europe mainly, but you'll see there's a UK, it's and Norway is the one in red. You see this is a kind of total energy. I don't know why. I'm not quite sure why Italy's in there. Actually, I should check that out. Not exactly North Sea, so it must be in Europe as well. But the rest of this stuff is the North Sea. So we see this building up of this energy offshore, out of sight, out of mind, way off there, by and large. But, and there's a but, this is what happens when you carry on to here. That's real, and then this is what's forecast. What we see really is that both in the UK and across the whole North Sea sector, this is gas by the way, we're into gas, and the oil shows a very similar trend, is that we're on a decline. We're not finding the gas reserves, the gas fields, or the oil fields of any significant size that we were doing at the start. The ones that we are seeing, the production costs are getting higher for a whole set of reasons. And that means that the revenue from the North Sea is dwindling. But the main reason, one of the points, is that we are no longer getting as much gas out of the North Sea as we were 10 years ago. So in terms of the gas and the oil, we have peaked. The North Sea peaked, Britain peaked early, Norway's peaked as well. So broadly, that is a sector in decline. And that means that this is the top graph looks at gas demand against gas production. This is for the UK. And what you see is that for large parts of that, well, when we get into the kind of late 80s and early 90s, we start to see some of the production over top in the demand. But largely we've got gas demand, us, for all this stuff, for our plastic food stocks, for our heat, for our fuel, etc., greater than what we can produce. So this graph kind of just shows the UK kind of, this is for a net importer up here, net exporter. So in the 80s and some in the 90s, we had so much gas coming out of the North Sea, we're actually exporting it. But that's not the case anymore. Increasingly, we're importing our larger parts of the gas. And one of the main imports that we have is through these terminals. This is the Isle of Grain in Kent, where these huge ships that travel the world, you know, the kind of routeways that they take from various places, traveling the world to bring gas to our shores. Their main source, in terms of the ocean one, is from Qatar in here, so the gas is produced in Qatar, compressed there, comes all the way around, and then docks in either in Pembroke or in Isle of Grain. And the problem with this is, well, there's twofold problem. One is that we don't really know much about what happens in Qatar in terms of, there's obviously the kind of political aspects to that, but also in terms of environmental aspects. But the key one really is when a container ship leaves there, a tanker leaves there, it's at the mercy of the global marketplace. In other words, if it's bought by us in the UK, and then someone else says, well, we'll offer a bigger price, then what happens is what happens with that ship in the right-hand top right. It just changes. So one of the things that's happened, for example, in the last year since March 2011, the Japanese earthquake affecting Fukushima and Japan stopping its nuclear power, is that Japan is now willing to pay top dollar for gas. So a lot of the UK supply, the Europe supply, now doesn't come around here. It actually goes off to Japan. So the point is that we're at the end of a one route way for gas, where we're just a customer like anyone else. Okay, next one. The other one, and we've seen this played out in the news really, is that the other big supply is, we have a significant supply from Norway, and you see Norway is declining as well. And the other big one is Russia. And so all of the controversy with the Ukraine and whether Russia, when Putin will turn off the gas, is a real important one, because that gas goes into our system, and again there's a complicated pipeline system through here, and the UK is one point at the end of that. So what I'm getting at is that we are dependent on gas for a whole set of reasons. It's our main energy supply at the moment, and yet it's looking as if the main suppliers of that gas is problematic. So I just want to shift the focus a little bit, and I want to go to the States. Because the States is an interesting case study, and really if we're talking about shale gas and fracking, because nothing's happened really anywhere else, it's where everyone goes to have a look, both good and bad. And so it's getting sense to do it. Can we get the lights down just a little? Is that a problem with the cameras? The lights down, is that a problem with the cameras? No? Can we just, So the reason I put this up, because it really illustrates the sheer energy demand that's going on in some of the states. So you see all the eastern cities all lit up there. You can see the west of a few less. You can see California, you can see there's Denver, you can see there's Salt Lake City. What's that one up there? No, she kind of goes over here. It's not in Canada, that's a clue. It's not reached Canada yet. Canada's a little bit further. All the lights go off when you get to Canada. Well, it's a trick. Next question. This is not a city. These are the lights of the gas fields of North Dakota. This is shale gas. Well, it's actually shale oil. This is the flaring that goes on, where you're taking, you're getting gas out, and in order to demonstrate that that gas is flowing freely, a proportion of that gets flared off. So a lot of it gets trapped, well, most of it gets trapped and taken away. But this is the outward sign, and you can see there in that top left then, that you can see now it's not a city, it's just a spread of gas flares. So what we see then is we see that's, this is up in the Williston, which is up in what's called the Bakken, which is one of the areas of shale. So maybe I should say something about shale sooner, because shale is the most boring rock in the world. Now many of you may think that stones are boring anyway, but even if you do, still shale or mudstone is the most boring rock. And for many years geologists more or less just have ignored it. It is mud that's turned into stone, which we call mudstone. It's very technical. So it's squeezed tightly shut, and it's just everywhere. It's the most common rock type on the planet. And this shows the areas in the States where there's got significant amounts of this mudstone or shale. Shale just has a little bit more competency to it. And what we find is that in the late 90s, two technologies that had been happening offshore come onshore and get brought together by small operators, not the big ones, but small operators. There's two technologies. One is what's called directional drilling, and it's developed largely in the North Sea. It's the ability now for drills not just to go straight down, but actually go down, they bend, they curve around, they can do all sorts. But the key thing is it can come down and go run horizontally. That means, I need to put this water down. That means if you've got a layer of rock, in the past you had to go through it like that, which meant you only actually got a little bit of it. But now you can actually run right along that layer and you're in it. You can actually go up and down it, move it across. Extraordinary technology now. So one of the ones I went to in the States, the seam of shale was 8 foot thick. And they were following it as they went with the drill. And the other thing was that was a mile and a half down. So a mile and a half down, hit somebody 8 foot, moving along. The other thing is the idea that within that shale is very organic rich, but we've never been able to get it out because the gas or the oil is tied up in tiny little pore spaces amongst the clay minerals in the shale. So what the approach has been in recent times, and again something that's been used extensively in RSE, is to inject down fluids at high pressure to just crack open that shale. Now the problem is that you've got a mile and a half of rock sitting above that weight. So if you crack open that shale, it just shuts again. All those cracks just slam shut. So in amongst that water, millions of gallons of water that gets down to bang open those shales at that particular layer, you get sand, large volumes of sand put down. And those sand grains just get flushed into the fractures. So when the fractures squeeze shut, they don't shut perfectly and the gas can leak out. And so that mixture then is used to break open the rock, and when it does, the gas then is able to come back with the water from the surface. So that's the essential bits of it, fracking. We'll maybe come back to this in the Q&A, because it's a really simplified version of it. The key thing is that gets developed in the Barnett of Texas, and then very quickly it spreads across Louisiana, this area, what's called the Haynesville. Now this is all onshore oil country. This is Texas, Louisiana. The onshore drilling is not new. They've been doing it for 100 years in some cases. What's new is it then switches up and goes up into the Marcellus, which is in Pennsylvania. Coal mining territory, not traditionally been oil territory. That's not true. It was oil territory. The first oil well was drilled in Pennsylvania. But the main dominant thing has been coal mining in the latter part. But suddenly oil comes on shore. And then what's happened now is it's then switched across up to Williston, but it's also scattered. So it's gone all over the place, all over the States basically, this growing. And the reason is, shale's a common rock. Lots of places have got shale. So what happens, and I just want to take you through the kind of key stages in, when you've got some shale and you want to then start to exploit it. So what happens is, a drilling rig arrives, and in that drilling rig, you can see it there, for a period of about 4 weeks to 6 weeks, drills down. This well is going to go down a mile and a half or so, and then it's going to go to the side, a lateral, and it can go as long, it can go a mile, 2 miles laterally as well. So you can end up with it over the hill, basically. So that's what it does. And then that moves away, goes off and starts doing another drill somewhere else. So what we've done is we've drilled this thing. So this is the point of, you've got a drilling rig here, it's all the way down, goes into this layer of shale, and then it's cracking open that shale rock there. So it's enough pressure to open up the shale in a narrow package of rocks that's needed, and then for the gas to come back up. And when that drilling rig goes, it's replaced by this, a paraphernalia of pumps and lorries and trucks. So you can see that the site's been cleared, netting and everything has been put down. We have these stuff on top of that. And then what we see in the red there, if we have the next slide, we see that is fracking. These are high pressure compressors with high pressure, which take water and pump it down. That's the drill head there. Pump it a mile and a half down there to crack open the shale gas. And that can be done several times. And one of the things that's happening now is from one pad, so that's a pad, you will typically have maybe 10 or 15 drill wells that go off. And then from each of those, you might have other laterals going off as well. So you've got one side and maybe 40 drill holes that might be going off potentially to go and do this. It's kind of like this monster kind of event. And so that's what's going on. And you can see the amount of clutter you need. The amount of sheer machinery and people, and all of those people have to be supplied, they have to live somewhere. It's kind of like a circus that just kind of comes around, and each frac pad has got all that. Okay, next one. Needs lots of water, so frac jobs typically between 3 and 5 million gallons of water, so it's extraordinary amounts of water. What's surprising is when you look at other things like how much a shopping centre uses in the weekend, how much a golf course down in the southeast uses. A huge amount of water. It uses a lot of water. That water in the States, they will inject it, bring it back up, put it in these ponds, inject it, put it back up, put it in these ponds. It's kind of constantly getting reused. That's one of the big issues they have in the States. So lots of water, and you can see this truck here that's actually just delivering water. In the next slide, you see one of the real problems with it is in the States is you need lots and lots of trucks. You need trucks to bring in the water. You need trucks to bring in the sand. You need trucks to bring in the chemicals, because those chemicals you need to be able to get that water really doesn't want to be injected down 1.5 miles. So you make it a slicker, smoother one. You have to put stuff in it so that when the bacteria starts to grow in the fractures, because there's lots of organics in there, there's chemicals that actually stop that bacteria developing. So there's a whole lot of stuff that has to be injected in. And as we'll see later on, this is one of the big bugbears of it. And what are we left with? What's that craziness go? So they're maybe there for maybe 6 months, depends how many frac jobs they're doing and all the rest of it, depending on how complicated they're making. But when it finishes, that all clears off, and you have, it looks like a big car park. That's the area that would have had all this. This is actually the well. So that's bringing gas up, and gas is getting piped off somewhere. You can see, can't see the pipeline, but that break in the forest in the top left is where some pipelines would go. This is actually, I said about the water, it's about 30–40% of the water comes back immediately, but a lot of the other water come back very, very slowly over time, and it gets collected in these condensate tanks here. And in some places, this is a photograph that I took in Pennsylvania. These things are kind of tucked away. You don't really see them, but you often have to ask people, where are they? There's one down there on the hill, there's one in the woods there, etc. Next one. But elsewhere, it's not as, it's a lot more obvious. So this is Louisiana. I took this photograph from Shreveville in western Louisiana, and every one of those squares is the frac pad. So, in some parts of the States, in the old parts like Texas and Louisiana, where onshore drilling was very common, and where this really started under the radar, it wasn't in the Environmental Protection Agency, didn't have any coverage. Basically, these small operators just started like a tsunami of drilling that went around. And even the big oil companies really didn't have much, they weren't even looking at this stuff. So this just went across, and that was the kind of effect that it had. By the time really fracking gets to Pennsylvania, the people are starting to notice it, and practices have changed somewhat. So it becomes a slightly more muted affair, but arguably even more contentious. We'll come back to why as well. Next slide, please. So I've got this. It's quite hard to get at what people think about fracking. Partly because it's so emotive, and partly because it's gone under the radar really for the last kind of 10 years. So what this is one of the few studies that's been done on what communities feel back in that the Barnett of Texas, that area that was kind of first used. So this is general. You won't see the details on this one, but basically it's asked communities about it, and negative views. There's two counties here. There is Wise County and Johnson County, sorry. And Wise County's had fracking for 8 years, and I think Johnson's had it for 3 years. And to be honest, it doesn't make much difference. You'll see that it's strongly skewed negative. So people broadly have got a negative view in these communities. So next slide will show you a little bit more detail. Okay, next one. What I've done is I've kind of blown up. So let's look at the negative one first. What's the top one? Increased truck traffic. Then I think the next one is the amount of, I can read that now. Is it my eyes or is that just gone? It's all.
Something by gas producer?
I think it's about tax actually for the gas producer. Then there's worries about the aquifer. I don't know why it's necessarily. This is air, noise pollution, water pollution, traffic accidents, loss of privacy, environmental quality, land quality. There are issues to do with environmental quality. So it's about pollution. That's the worries there. And on the right-hand side, what are the benefits of it that's perceived? Apologies if it's not very clear. It's availability of good jobs, fire services, quality of local schools, medical services, police services. And that's the balance, because what happens is the gas companies put money into the local community for infrastructure, and what that means is you get beautiful roads, fantastic roads, but along those beautiful roads come thunder and lots of trucks. You get situations where in Pennsylvania, something like 25% goes into what's called the school tax, goes into the local school. So you can keep open small hospitals and small schools that otherwise would close, but at the expense of people's worry about more people coming into town, more traffic coming through town, worries sometimes about rising crime because more people are in town, and sometimes hard to get rental places because all of these people that are coming in and moving through for the fracking and taking up the rentals, and local people can't get on the housing market. So I think what I took from these places is that it can be truly transformative, and there's a plus and a negative side of that, and it kind of depends where you fit in that community, whether you're going to see a kind of as a win or a lose situation. The most reason why people are very worried about fracking is this. This is an image from Pennsylvania of someone lighting a tap in the morning and getting a surprise. Now, we've actually filmed at that house, and I tried to light that tap actually, and I couldn't do it. It's not. I tried it at 4 o'clock in the afternoon, and the problem is that the build-up of gas is biggest overnight, and then as you run the tap, it gets less. So if you do it in the morning, you can light the tap. If you try it in the afternoon, it's kind of gone. It's quite funny because we said, "Oh, it's fine." She said, "Come back tomorrow," and we said, "No, it's all right. We got to go." And as we left, she was running down. So I can light my kettle. I don't know why they like it, but the point is, this is happening. So next slide. So one of the big worries and this isn't across the board. This isn't in all areas. This is in particular areas. In the Marcellus, this is the area of Pennsylvania. It's particularly bad for this. Is that there is methane, that organic-rich mud that is underneath is actually got lots of methane in it that it's leaking out. It has been for years. People have been able to light taps in that area for decades. But what's happening is that two things, I guess. Fracking is given more focus, but also there are studies that have shown that there are increased levels of methane leakage close to sites where fracking is going on. So this is the house. That's the actual house that we tried to light the tap on. And as you'll see, we're just round the corner. Next slide, please. What we see there is lots of local kind of worries about it. Next one. And this is Rob Jackson, who's a chemist geochemist from Duke University, North Carolina, who's kind of the leading expert now looking at the water contamination issue. And he's basically, so the pipe, the well is somewhere in the garden and it's taken off and then it's attached to the house where they draw their water. And we looked at that, we did a horizon on this, that is bubbling away with methane, just it fizzes, it's fizzing away the water that's there. So the science that we've got in this says that there's methane that is coming out. It looks like the studies that Rob's group has done suggest that when you get closer to areas of fracking sites, that seems to be elevated. What they think, and the general consensus of those involved in it, from the scientific point of view to the actual engineering point of view, is that what's happening is that it's not that you've had this fracking going on down here, you've fracked that rock, and then that methane gas that you've released has come up to the surface. What they think is happening is that rock is leaking methane, and we're putting down boreholes drill holes that should be protected by concrete and not let anything in, because that's one of the problems. When you do this, you don't want the drilling fluid to leak into the rock because it's very expensive. You protect your hole, you get the stuff down, and you don't want stuff coming in. But if you do this job quickly, because you've got to get your drilling rig onto somewhere else, or you just can't be bothered to go all the way, drill, put concrete all the way down to 200 metres and you stop 150 metres, then you leave gaps. So what they think is that the poor well engineering is making basically lots of holes that actually that natural rethinking come up. The reason we think that is because there's no scientific evidence that the fracking fluid, remember I mentioned those fluids, that the fracking fluid has actually been found in surface drinking water or surface water. Now, it has been when there's been a traffic accident and a tanker has overturned and lost its load and it's gone straight in. So there are evidences of fracking fluids in water from that way, but not from really from deep. So this is one of the key issues really in fracking debate about water contamination. And the science is evolving, and because it was done under the radar, scientists are trying to catch up. I'll come back to some of the differences in the UK, but the point is in the States now, they're going back and they don't know basically what the methane levels were 10, 20 years ago. They know there was stuff coming in, they don't know how much. So it's almost an impossible situation to say how much to do with fracking, how much it's not to do with fracking. So it's clear that, that there's potential water contamination effects, and actually there's other things. I mean, from the fracking pads I showed all that activity. I mentioned noise pollution, but actually air pollution is probably more problematic. And if we're talking about health effects, the main health effects are to the workers that are there. It's the ingestion of the sand dust when they're putting the sand in. These are the guys carrying the chemicals. That's where it's occupational hazard to those that are actually working inside. It's by far the most problematic health effect. Trying to work out the other more distal health effects that are going on, spread across the community, is much harder to do. We just do not have the long-term data because it's not been long-term. This has happened really fast over the last 10 years. But the science we have got suggests that the contamination we do know about, well, the leakage from the methane is coming up from bad engineering of wells, shoddy well activity. That will make you feel better or not make you feel better at all. Next slide. But it's clear that, that it has effects. This is Janet McIntyre. Janet and her husband drills wells. He drilled a well, and it's a very good well. Such a good well that almost the whole community of Woodlands where they live would get their water from Janet's well. But they started feeling ill, both of them. Nausea and headaches and things like that. They just thought it was slightly weird, but they were both in the well. Some days they just wouldn't get up, wouldn't be able to get out of bed. But they found that whenever they went away to see family, they felt better. They coming back. It was a bit odd thing. They didn't really think too much of it. They didn't think too much of it until the grandkids one day rushed down when they were over and said, Gran, why is the bath full of pink foamy water? And something had happened to the well. That was a kind of realisation. Now, just a few months before a fracking job had happened, about half a mile away. And they're convinced, and this is the most likely explanation I have seen, she's very, very ill. Lots of debilitating illnesses, a real cocktail of illnesses you've got. What they believe is that the fracking job was done badly. The well wasn't cased, they said, protected properly. Stuff leaked out and leaked into the shallow water supply and contaminated their water. And remember, in the States, a large part of the States that are rural, spread out, most people get their water from those drill holes. In the cities, it's different. It's like here, we get it piped in from reservoirs and all this. But a lot of rural America still gets the well from that. So if you screw up one of those shallow aquifers, you know, it's a real devastating effect for people. So now, Janet and 20 other homes in that community only drink, wash, bathe, everything with bottled water that comes in from a church charity. Next one. C.B. Leatherman. He doesn't look too upset. C.B. Leatherman's in Louisiana. And C.B. Leatherman's got a big patch of land. And the gas company came to him one day and said, we want to drill for gas under your land. Now in America, unlike here, you generally own the mineral rights underneath. Not everyone does, but most homeowners would own the gas rights. So the gas company has to pay you to take that gas out. And in CB's case, he got a cheque for, I think it was something like, his first cheque was 400,000. But he gets an annual payment from the gas company for doing nothing, for sitting in his front lawn, of about 300,000 every year in profits for him. And every one of his neighbours does too. So he's got quite a lot of land, but he says the couple across the family across the road, who are very poor, they get a return as well. He's a smart one, this one. He actually has dug out a huge lake on his land, which fills with rainwater, which he then sells the water to the fracking companies. So he wins on wholesale. This is why there's a nice smile on his face. So the point is, there are winners and losers. And it's judging, it's trading off this, and it's really about values and where you place yourself. There's a survey done in Pittsburgh. So Pittsburgh is one of those cities that's really come back in terms of the bounce back economically really in the last 10 years, largely on the basis of shale gas. So this slide here on the left there says, to what extent does you think the Marcellus Shale, that's the shale that sits underneath Pennsylvania, represents an economic opportunity? Now the key ones are the two top blues, because that's significant and moderate. And what you'll see is dominant. So yes is the answer to that. Yes, it's a significant economic opportunity. Look at the one on the right there. To what extent do you think Marcellus Shale represents a threat to the environment and public health of the region? Now the interesting one is this one here, these colours, which are significant moderate, and again the answer is yes. People think it is a significant hazard. And what's interesting is that relationship strengthens. That's the overall one. Allegheny County is basically Pittsburgh, and then when you go into the areas where actually a lot of fracking goes on, it's even more. And it's that duality that I think is what I came across, is that I think people, the same people, will say yes, it's an economic opportunity, and yes, it's a potential environmental threat. And then they have to decide where they sit in that thing. It's one of the most common questions I get is yes or no. And the point that I realise from America is there's huge shades of grey in this. And it's really where individuals fall in amongst us. So this was the situation in America up till from 1990 through to 2006. So you can see that the offshore realm, Alaska wasn't really doing very much. You can see the offshore realm, the Gulf of Mexico, had plateaued and was starting to drop off. The onshore, Louisiana and Texas and California, the great oil fields there, was dropping down. And it really looked as if America was going to have a real problem with its energy supply. Next one. But that's what's happened. So what happens here is we see an uptick, and this is shale gas. It comes from really nowhere to be, and then this is the projection. So based on the kind of proven reserves, they reckon that the US has got 80 years of gas supply. Just doesn't need to do anything else, it's just got it there. And so this is the reason why people are saying this is now a game changer, because this is cheap gas, domestic gas that America has got on its doorstep. And if you think about that, this is what I was saying about gas not just being for energy. What it's meant is an increase in reshoring. So a lot of the American companies, chemical companies, plastic companies, that sent their work overseas because of cheap labour, have now brought them back. Because although the labour costs are high in the States, the energy cost of shale gas is so low that they can make more of a profit in the States than they can in China. So that's why Pittsburgh and the East Coast and all that is booming again. Next slide. The other thing that's truly extraordinary is what it looks as if, in the face of it, it's done with carbon emissions. So America is a great polluter. It's the one that didn't sign up to any of the international agreements. It's along with China, pumps out more carbon emissions than anywhere else. And so for a while, so if you look at this as the real data back in the 90s, this is the trend it was on, and so this would be the forecast that was made in 1998, and this is the reality. And that idea that notion of America reducing its carbon emissions was an extraordinary thing that was even untenable to think about in the 90s. And yet the reason that it's managed to do that is because of shale gas. Next slide. And to tell you why it's managed. Oh, sorry, okay, go back then, sorry. I took one out because it was getting too close. The reason that it managed to do that is because shale gas price dropped so much that it outcompeted coal. And coal is a really nasty one. Coal is the one that really puts lots of carbon emissions up. By and large, it's a pint for pint. Shale gas is about half the carbon emissions of coal. Now, it's a little disingenuous, this, because basically what this did is it didn't mothball the American coal industry. All the American coal industry is they couldn't burn it in America. So they exported it. So someone else is now burning America's coal. And actually, by and one of those places is here. We are burning America's coal. So while America sees its carbon emissions going down, globally it's not made a blind bit of difference. That coal is still going up into that atmosphere. But it is extraordinary the effect that this has had in terms of its emission targets for America. And the point is, I guess the point is that if it offsets coal, then by and large, climate-wise, it's a very good thing. So there's the other thing. It's not just America that's got this. As I said, shale is the most common rock type. Everyone's got it, probably in large quantities. Is it the right coal? Does it have gas in it? They're the big questions. And here's the areas that people think have got significant. Senator of the States, Canada, Mexico, Argentina, really big ones, Brazil probably, South Africa, bits of North Africa, Australia, China. I don't know why Russia's not on there, we probably don't have the values for that, but Russia's got a lot. And the UK, you can see there's stuff in the UK. Poland in Europe is the one that's looks like it should have a lot, there's a complexity there. What I find interesting about this is look at the places that haven't got it. The Middle East. The Middle East doesn't have much shale gas, doesn't have much shale. So what people are saying is, they say, look, this is going to change the geopolitics of energy. You know, we've been dominated through the second half of the 20th century with the Middle East being the fulcrum because of that energy demand, our addiction to oil and gas. That's where we've had to have our attention. That's why we get involved in wars and conflicts and propping up governments across there. But if there's a new world order, then there's a whole set of new complexities. Everyone's got a bit of shale gas in their backyard. They can always go to that. They don't have to go to those few places in the world where you get really significant amounts of oil. So that's one of the kind of narratives that kind of runs through this is, you know, some exec said to me, and I don't believe it for a second, but he said to me, you know, this is the last, you're not going to see America get involved in wars in the Middle East now, because we don't need to, basically. We've got it on the doorstep, why we need to. I'll leave that with you. So let's go back to here, because what I'm getting at is that in America, it's been transformative. It's been transformative in negative and positive ways. But and so we look to America. So if you're for shale gas, you look to America and you talk about the economic story of prosperity, or you talk about it offsetting coal and what that could do if that was, you know, repeated around the world. If you want the negative aspects, you look at the community that's been affected, you look at these fears about water contamination, air contamination, pollution. Or indeed, you look to the idea that actually if we go wholesale into shale gas, into gas, we're sustaining a fossil fuel economy that the energy outlook suggested was on its way out. In 2006, most people would say, look, this can't go on, all the lines are going down, clearly, you know, the renewables are coming faster than we expected. Shale gas might well put all of that off. So, back in Britain, this is up near Castleton, Mantory, you know what I say, but that is the Bowland Shale. That rock sitting out there is a sequence that's far thicker than anything the Americans have got. It's less extensive laterally, but it's much, much thicker. It's a big valley. So we've got huge amounts of shale. And there's me with a piece of shale. That's a piece of the Bowland shale, so it's been a borehole down getting a sample of this stuff up. Can't see it very well, it's very dusty, but you can see the very thin layers in it. Those are the lamination, very thin layers of clay and mud, and inside that is trapped the oil and gas. Next slide. And there is a piece of shale. What's happened is that that's been taken out from depth, where it's under this great pressure of 2 miles or so of rock pressing down on it. It's been taken out and it's been popped straight into water. Next one. And then what you'll see is the gas coming out. Now what's interesting about this is, apart from showing that there's lots of gas in a piece of rock that we kind of knew was in there, but it's a case of how do you get it out, is it's not coming out of all of the shale. There's some bits where it's really coming out strongly, and there's some bits it's not at all. So there's a lot of stuff coming out from some layers in here, and some layers in here. But actually there's not much from here, and there's not much from there. And this is the problem. So when we talk about how much is there, we know how much shale is there. That's kind of easy for geologists to work out. But how much gas is there depends on how easy it is for the gas to come out. If a lot of our shale, when we get down and look at it, is like this, we're not going to get much out. But if it's mostly like this, then a lot of those estimates are going to probably be bang on, and there's lots there. But we do not know, because we've not gone down and actually found out. The next slide, thanks. So what we do know is we know where the rocks are. That's been known really for 100 years or more. We mapped them out. And so the areas kind of mauve here is this areas of the Bowland Shale that I've been mentioning. And you'll see the other places, it's called the kind of Carboniferous ones. You see the Midland Valley of Scotland, that's Carboniferous rocks of the coal measures. That's the coal mining territory of the Midland Scotland. And lots and lots of shale there. Some of them very shallow, and actually up in the Midland Valley it's much more likely to be coal bed methane, which we'll talk a little bit more about in the Q&A. But this is a younger set of shales from the Jurassic, and we know that they've got oil in them because here are the oil fields. There's lots of oil fields all across this area, so these are producing oil fields already. I mean, I think it's something that we forget is that there is an onshore oil industry in the UK. We just tuck it away behind, fences and things like that. There's an extraordinary one here. I have to talk about this one. This is Europe's biggest onshore oil field, and I bet you no one's ever heard. Well, I'm saying that. Some of you should have told me. Witch Farm. Witch Farm is 30 years old. It goes down onshore and it directionally drills offshore, where it fracks an offshore reservoir beneath sandbanks. Sandbanks is the highest, most expensive real estate, certainly in the UK. This is the area, the pristine area of the Jurassic Coast, the UNESCO World Heritage Site. You don't know about it because it's been operating perfectly fine for 30 years. Fracking and directional drilling. I bet you now, if you try to say, we want to create Witch Farm now, it wouldn't even get past gold. So we've got this issue that the first thing is, there is an onshore industry. And that, in many cases, that's been produced. So in this area here, it's largely oil, and that oil comes out broadly without needing fracking. The expectation is that in these areas here, the gas is probably going to need a little bit more encouragement to come out, which is why it's going to need fracking. In terms of where you are, I think iGas is got a set canopy. It's a set canopy which used to be dark and it's now iGas. There's a small patch. It's not very expansive area of shale, but that's the closest one. I'm not quite sure why it's not on there, but it's more recent to this. So there are things that are in the area, but you can see large area of the country are not. Over here we've got shales, and shales are too old. They've been cooked up, messed around with, stuff's gone. Southern uplands, your landscape is shale. Mountains, that was a seabed, ancient seabed, when Scotland was part of North America, England was part of this southern continent, the muddy seabed, as they two came together, crumpled up, produces these big folds. All of the gas, all of that organic stuff has more or less gone from there. So this area isn't going to be shale gas country. Next slide. I want to finish though on this issue because one of the questions, we don't know how much shale, geologists about this, we don't know how much shale gas is down here. So we know how much shale is, but we don't know how much gas there is. So, but one of the questions is, if we develop it, why are we developing it? And one of the arguments is that we're developing it because of our energy fix. So, I highlighted before that actually gas, particularly, is much more important in terms of fuel, and heat, in terms of heat, in terms of plastics, in terms of clothes, fertilizer, all the kind of chemicals. But let's just look at energy, because it's a dominant part of it. This is the graph of the energy supply. So the purple is energy supplied. The green one is the energy that's been available, the potential energy in the whole system through time. The purple one is the energy that's actually been produced for us. And the orange one is the energy that we've actually used, that kind of demanded. And you can see that our energy consumption shows no sign of going down. So we are using more and more and more energy steadily across it. And it's very hard to see that that graph is going to do very much more dramatically, change very dramatically. There are little fluctuations in here, but the broad, you can see that there are one all the way through. The trend is upwards. This earlier on, I was plugging in my iPhone. We just use energy, you just suck it out up that little mains plug-in thing, we just use it. Next. So one of the things is our use of energy. So if shale gas is going to come in, it's going to come in under that energy bandwagon, or the sort of band. So here's a national grid. Next slide. Thanks. And I went a few years ago, a year ago, I went to the National Grid's headquarters. It's a secret place outside of Reading. But actually, I say that, there's actually two of them, absolute mirror images of them, in case one gets taken out by, I don't know, by something, and it goes down, and they've got a television where they see the others. It's the weirdest thing, and they can watch the others, and they're exact replicas of each other. But they're top secret, so top secret that when I went to Reading Station, I said I want to go to National Grid headquarters, they said, which one? And I said, I don't know, and the taxi driver told me all this. Which the others confirm. Next slide. So in this hub, this is where your electricity gets juggled. So your demand's going, so they're watching your demand, and they're trying to say, right, how do we do this? What have we got to play with in terms of the energy? Let's put it in, let's bring this on, let's shut that down, etc. So the next one, what do they got to play with? Well, the dials they've got is that's the kind of total demand. Can't even see these now. So this is coal. They've got coal to play with, they've got nuclear, they've got gas, they've got wind, and up here they've got hydro. So they've got all these things, and they can bring some on quicker than others. So hydro, press a button, hydro station starts. Nuclear power stations and what they call fire oil power stations are on. They just have to be, you can't switch them on and off. So I thought it'd be interesting to have a look at the energy. Next one, please. This is next one, sorry. Yeah. This is a typical winter's week. It's February 2013. And what we see is, so Monday to Sunday, and blue's coal, red's gas, green's nuclear, and the purple one is renewables. It's wind, but also I think hydro's in there too. And what you see is that you see the coal underpins the whole thing. And you can see the fluctuations. You can see that sometimes it's windier than others, and sometimes wind contributes more. But the holy trinity of coal, gas, and nuclear is what's carrying us through when we get that. Next one. This is going to be the year. And I think it's 2011 through to 2012. And I know it's 2 years because I can tell you that. What day do you think that is? Christmas Day. That's when Christmas Day. Because all the factories have been shut down. I mean, I know you can telly on and do cooking and stuff like that, but large-scale energy consumption is kind of muted for that type of thing. But again, you can see the dominance of those three, of coal, gas, and nuclear. And so you can have this, I've got this app, again it's called UK Energy, and it can tell you what it was today. So it's 24 hours from 7:30 today is you, when you press that switch, in terms of what energy is going to come out to you, 34.8% of that is gas. 15.4% is nuclear today. Wind, 1.8. Pump storage and hydro together, so non-pump to basically hydro, 2. Stuff we get in from the continent, 4.9, 2.4. Do you want to know the winner today? Coal, 36% of our electricity is from coal. So, this is the point. We need to think about where our energy is coming from. Because if I was going to do this and I forgot to do the maths, I was going to work out what that percentages would be. And if it came to renewable, there'd probably be 3 people in this audience standing up to represent in that energy mix what renewables is. And what I'd say is that almost everyone I talk to in the energy industry recognises that we have to get to a renewable future. It's a low carbon future is an absolute must for a whole set of reasons. The question is how you get there. How do you get it from like an audience that's with 3 people representing renewables to renewables representing 60 or 70% of what we want. Next slide. The problem's compounded because we kind of know what's coming, I don't excuse the pun, in the pipeline in terms of energy. So this is it's kind of a complicated diagram, but essentially we've got, this is for each year, what is the part of the energy mix. So 2012, this is coal, this is gas, what else? There's a little bit of oil in there, there's nuclear, there's hydro, and there's wind at the top. So that's our kind of stacks kind of system. So what we also know what's coming. Because, big wind farms and stuff like that, they're long-term processes. We know they're in planning or whatever it is, they're getting built. We know what's coming on stream. So we can do this right the way across for the next few years. And what you see is coal dropping down. That's because a lot of the European regulations on air pollution, the sulphur components, are meaning that a lot of our coal-fired power stations have to shut down in the next few years. We also see that nuclear one shrinks a little bit because a lot of our nuclear power plants are getting to the end of their life plan and they're going to go moving out. So as you see some of those drop down, you see that to some extent that's balanced by the renewables, so that we've got more wind here than we had there. But next slide. What I want to show you now is the spare capacity. This is what people get worried about. So basically this line says, that 0 line there, is if it's below it, this is energy that's been taken out of the system, shut down to nuclear power stations or shut down to the coal-fired power stations. And if it's above the line, it's new energy that's coming in terms of, well, you can see it's generally, it might be gas, it does blue, but often it's actually renewables, the wind or hydro. Well, not hydro, hydro is more or less at its limit. And what you see is that at the moment, that I said about the available energy that we've got versus what we actually need. That difference of what that extra carrying capacity is about 16%. We've got spare, by and large, we've got 16% energy in the system spare if we need it. It's a really bad winter, we have some kind of, a nuclear power plant gets shut down, fire at the Didcot or something like that, something gets taken out of the game. 16%. But you can see that more has been taken out than is going in. And so that spare capacity goes down and is predicted to be about 5–6% in 2016–2017. And that means what people worry about when you hear this stuff about when the lights go out, doesn't mean the lights are going to go out, but what it means is that if we have a really bad winter in 2016–2017, we may not have enough energy. Now, you won't see it, first, the big industrial people that have made special deals with national grid to basically power down if we have a crisis, they will see it first, businesses. But you can be absolutely sure you'll see it in your wallet in terms of money getting passed down the line. So it's the energy precariousness that we're seeing. And the point is that, so we've got a more precarious energy situation. If you put it alongside the stuff I was saying earlier about, the fact that gas is such a dominant one, the geopolitics of gas as well, we're going to be more reliant in 2016 in imported gas than anything else. That's the one big chunky bit of energy that actually we were going to need, and we're going to be needing it more from Norway, but their supplies are going down from those other parts of the world. Next slide. And then we've got climate change. How do we balance this? By 2050, both in the red, the UK, and in blue, in Scotland, have gone for 80% reduction. Next one. By 2020, we're a bit more ambitious in Scotland, 42% versus 34% in the UK. What was it last in 2012? Next one. Going up. And the reason it's going up is because we're burning more coal. And we're burning more coal because coal is very cheap and because we don't have enough extra capacity from some of the other things. We're not that keen on nuclear. We're not that keen on wind. We're not that keen on gas. We're not that keen. And so what we're trying to do is to end up burning. Now that will stop because a lot of those coal-fired power stations will have to close. They're burning it while they can. But one of the big issues here is how do we get out of this by still managing to meet our climate targets? Because it's really crucial that those emission targets broadly get hit. Otherwise, we really are into the area of dangerous climate change. We can completely separate talk about that. But and the last one is this is for me the problem. You know that photograph I took of Malmtor and the Bollinger? I turn this way and you see this. This is Castleton, beautiful part of the Peak District. So let's imagine that you could drill under there for shale gas. And, you know, as I say, that's perfectly kind of reasonable. There is industry in there. You can see a cement works. That's the main employer in that area. And then cement, very, very, in terms of high emissions for carbon. It's an old mining area. That was a Blue John mining where they used to go into the rocks and that was its main economy. But now, of course, apart from the cement works, the main economy is B&B into tourism. And what do you say to a community like that that says, well, actually, maybe there's economic gas underneath you? So on the plus side, talk to people, they say, great, that's jobs, and there's some economy, and you know, we need some money into this place. On the other hand, other people are saying, look at this place, it's beautiful, it's pristine. This is why people come here. Are they going to come here if there's fracking rigs and trucks and all that going through? This is quiet, in little villages, windy roads. Are we getting new fancy roads with lots of trucks? You know, the lesson for America is that shale gas is transformative, but not in the same way. One of the ironies, of course, is that in the UK we do not own the oil and gas rights beneath our homes. We don't also own the precious metal rights as well. The state or Queen is the only person who's got the right to drill and explore for oil and gas. I love the idea of drilling. But anyway, so people are not going to get rich in the way that they did in America. But equally, we've got the best set of environmental legislation in Europe, and far better than anything they had in the States, where actually the shale gas that was exempt from the Environmental Protection Agency. They weren't even allowed to look at it. They were exempt from the Water Act. So we have a very stringent, robust environmental legislation. And I'm just going to leave you with kind of a moral, I'm right in a minute, I really get pulled either direction with this. But one of the interesting moral questions is what is more moral? Is it to import gas from around the world to keep our addiction going? Or should we use the stuff that's actually underneath our feet and do it in an environmentally responsible way? And so that's the dilemma, that's the kind of fulcrum that the dilemma about shale gas is resting on, is we're going to need some of this stuff in the next few decades. It's almost, certainly years, more like the decades. It's pretty clear that gas is in there. And Ineos had that thing in the last week, 650 million to keep the Grangemouth going. Gas is in there. The question is where we get it from. Do we get it from somewhere else in the world with dodgy politics and dodgy environmental regulation and just say, well, we don't care, we're clean here? Or do we actually do it here and do it properly? And that's the dilemma that people are in. So I'm going to leave you with that. Thank you very much.
Fantastic talk and brilliantly delivered. Now, there are two minders here of me from the Royal Society of Edinburgh, Kate and Rachel. They've told me that I will turn into a pumpkin unless we're out of here at age 15. I don't know how Iain is, because he's still got to have his dinner as well. My goodness me, he's son for it. But I think we have to have
sorry.
We have to have time for questions. So there is a microphone. And what I'm going to ask you, Rachel will bring the microphone to you, and Rachel, I'll try to indicate, after you've asked your question, I'll try to indicate to Rachel where the microphone is going to go so that we can really roll. And I'm going to extend this for as long as Rachel will allow me. I'm standing there once. Right, first question, Iain.
You talked about chemicals being put into the water to make it slicker. What are the chemicals that are used?
So you can go, there's a whole set. Most of them I've never heard of. You can go onto the websites, so in the UK and large parts of America, and you can go onto the websites of the companies, and they're required to state all the chemicals that they've got. One of the things with the chemicals, the Environmental Agency legislation prohibits the injection of any chemicals that are classed as hazardous. So any chemicals that are going down will not be classed as hazardous. Now, that still doesn't mean that they say it's very nice to drink, but actually, one of the things the industry has moved to now is what they call food-grade chemicals. And you will see, MDs seem to do this now increasingly, is drink the fracking fluid before you put it down. So, just as a background, one of the big issues in the States was the proprietary nature of the chemicals. The industry was essentially not regulated in any sense. People were putting down and hiding behind the fact that these were company proprietary things, and they kept. Actually, everyone was using pretty much the same thing, and actually, a lot of them were pretty horrible stuff. But what's interesting in the last few years is that the public revulsion of that notion of just injecting down lots of things, acids, for example, they do something called acid etching, which is trying to keep that bacteria, to keep those pores open, means that there's acids that gets put down as well. So this is a huge issue. So the idea, in the UK, the regulations will be, you cannot put down hazard substances. You have to list what those substances are on a publicly available website. And when that water, and you know, I was saying in the US, the idea of them recycling all the time. Well, the initial thing was that's bad. And the reason it's bad is that as that water goes down, it comes back up, it goes down again, lots more. It takes up that nasty stuff in the rock itself, so it gets more and more concentrated. There's a bit of a trade-off in the UK. The original idea was that it was just going to go down once, and then it would go to a waste treatment plant and go through the normal process, except it's got high levels of radioactive material, and then there's a whole different process for that. But actually now they're actually arguing that they might have to treat it on site so that they actually can reuse. And the reason for that is to reduce the water traffic transport. So it's a trade-off between trucks carrying lots and lots of water and chemicals versus actually trying to recycle it on site. But it's absolutely the most potent aspect of the whole fracking debate, because it's come from America, where it's really got, as I say, it's very easy to find lots of things about these horrible chemicals that just get used. So I think, I don't know what they are because I'm not an oil and gas person, so I don't know what these things, but there's been a big change in the last 10 years about regulating that whole aspect.
Rachel? Yeah, good question. Anyone else?
I
Thank you. I was particularly interested in the bit about the gas coming up in America.
Yeah.
Because a civil engineering friend was telling us recently about a terrible disaster in Lancashire back in 1984, known as the Abbeystead disaster, when there was a huge explosion and 16 people died because gas percolated up from old coal workings.
Yeah.
And his question is, if fracking proceeds, how can we ensure safety in basements, sewers, manholes, and other underground chambers if the same sort of thing happens?
It's a good point. I might go to the slide. Yes, there was that disaster. I mean, gas build-up, gas drilling has happened on shore, and it's an industrial activity. When you get a build-up of gas, you have these explosives. One of the interesting things in the coal mining area, of course, is that gas has always been a hazard. And in fact, in the coal territory, one of the key things is we have to get rid of that methane. So the coal authority and bodies actually extract that gas, because if there is a build-up, it can cause explosions. One of the ironies, it's an aside really, but one of the points of the whole coal bed methane is that if we're actually taking that gas out, should we use it for energy, or should we actually just get rid of it? So it's a very much a hazard. I think that it's this notion that you know, as I say, because we're going a mile and a half down, the gas that's coming out of the surface is much. It's not as dramatic as in the States, for example. I can assume volumes numbers. But I think the key thing is it's an industrial activity. There will be accidents. I think that it's almost impossible to think of a major industrial activity that happens in any kind of scale where there will not be accidents.
Especially early on.
Especially early on. And this is one of the absolute crucial things, is that if you talk to the technical people, they say we can do this right. We've got all the technology there. But human nature tells you that some of that will go wrong. We've kept all of these things. And I think I would say, my argument would be, this is part of what happens when you have an industrial chemical process.
And lots of people get killed, with many thousands every year, with coal.
Question at the back. It's a wee bit similar to the last one. It's actually just, they were fracking, I think, in Lancashire a while back, and there were allegations that it was causing damage to houses and earthquakes. Was that ever proved or disproved?
You're talking about Quadrilla's one in Becclesall, and that's the only place where they've tried to do fracking. So there were 6 hours into the first attempt to frack in the UK, and they produced earthquakes that moved the fault. They produced a magnitude 1.8, 2.2 earthquake. If you all jumped up and down, well no, if you guys jumped up and down, the vibrations that feel was magnitude 2.2. 3 people detected it, didn't cause any damage to the places. But one of the things about that is the size of earthquakes that we get there is the same size as you get in coal fields. So what's interesting about that one is, if you do a review across the world of fracking jobs, hundreds of thousands of fracking jobs, the number of instances where an earthquake has caused the fault to move and actually affected the drilling thing, Quadrilla, it's 3. So it will trigger earthquakes in the same way that when we build a dam, it changes the earthquakes. When we do geothermal, we put water down for geothermal, triggers small earthquakes. But it's the size of earthquake. The earthquake scales it's a logarithmic scale, and actually the size of earthquakes they produce a negative magnitude generally. So magnitude 1 or 2, it's quite big for the UK, but you wouldn't feel it. One of the issues that's coming in is, I think one of the things from the Royal Society report was saying, look, the companies will need to have some kind of insurance that if you do cause damage and it's led to be a cracked plaster or something talking, you pay for that and that has to be done. But the notion of this as a process that causes it, if you go to the States, no one talks about it. It's just not part of it. But we talk about it because it happened in the first 6 hours of fracking. Now, there's an interesting point there, which is that bad luck? Or is it telling you that our faults are differently stressed? We've had ice and all that. Is it different? And we don't know. And so the government brought in a traffic light in thing, whereby red, green, blue, if you trigger more than a magnitude 1.8, you have to stop and watch it. What worries me is actually 1.8 is quite common. And so I think that one of the interesting things is trying to get something so we can see if some of this stuff does it. And if it triggers a very, very small earthquake, then it'll all be off. And I think the first few would have to go absolutely right if the public's going to have any confidence at all in this.
We have last two questions. I'm sorry, second last here. Yeah. And then one at the back. I'm sorry, they've all. Maybe I should allow one. There's one. There's going to be a final question over here.
I was going to say there's no been any. Oh, there's been one. So
there's one coming. Right. Okay.
I'll shorten my answers. I'm trying to give long answers, but maybe I should.
I think we need
this is a short one.
Okay.
You were in America, right? And they move it around. They don't stay static. They leave back. So you're talking about a workforce, which is going to be a nomadic workforce. It's not actually going to bring work to the local area. For a short term it will, and not for a long term. Now, the difference in America, everybody makes a bit of money. The only people making money are the government.
Absolutely.
Not the people that live locally. So it's a different kettle of fish.
I think it is, and I struggle to think why a community would do it. And the reason is, because in America you make money. Now, it's not entirely true for jobs. So there's two things. The fracking crews move around. They're not going to be local jobs. They're going to be specialist crews that go around. We find a way, we have doing all that. In the UK, in Europe, we've got 1 rig and 3 crews. That's all we've got. So to start an industry from that, that's going to take time. So the jobs, sure, those guys are specialists and they're going to move around. The key thing is that the manufacturing base, to go from building 1 rig, that kind of stuff, now that might actually permeate lots of places, when they start to build rigs and all the stuff that goes with it. The other thing is that some kind of community benefit is going to have to come in. Otherwise, why would anyone take it? The community's carrying all the potential risk, and the benefits going to the country in terms of energy security, or if it's offset coal to climate. But that community takes it. So the kind of a thing at the moment, which is 100,000 and 1% revenue, for most communities will not be enough for them to risk that. But if they do get that, if it's a lot of gas, 1% of revenue is actually quite a lot of money. And if that's going in, that's saving lots of things. And then all your indirect businesses benefit. So these things are seen as catalysts. So the direct jobs of the groups going around, absolutely. And in America you see a boom and bust as that goes through towns, and that's a really boring thing. But I think jobs are there. I mean, not as a really obvious one, but they're definitely there.
Next one, please.
Yeah, I think what
Quadrilla
did was actually the best thing that could happen, because it made the government actually catch up and understand. Because a lot of places in America actually have no casing at all, and will be the only place in the world where we'll have triple casing. So I think so. But the main part of your talk is about, look, we need our plastics industry, etc. We need to get to low carbon. Renewables can't give us a plastics industry, but Germany's decided, like we have, we've got a lot of coal, and Germany's actually investing in carbon capture so that they've got security supply, because we've got a lot more coal than we have of shale gas.
Not a lecture on carbon capture, but what do you say to them?
I think carbon capture is a technique. So carbon capture is the idea of taking the CO2 emissions and putting them on the ground. In Germany, people don't like carbon capture for the exact same reason with fracking. To my mind, it's crazy. We put the CO2 underneath. They say, oh, but what if it leaks out and you get fizzy water? You drink fizzy water, there's a massive course. Where was that? It's the last one.
This is the
last good one.
Last one.
It's skew of those.
Yes, no, it's not. But as a biologist, I know how difficult it is to turn over a rumour with the truth. Now, what I wonder is the estimates of the gas that's down there must be very, very difficult to really estimate properly. Because as you showed us, the beautiful thing, lots of gas here, none there. How soon will we know what's really true and what's actually fiction?
There's two aspects of that. One is, I say, we know what the shale amount is, but we don't know how much gas is in the shale. And so there's been these constant things about trying to Volcom last summer, Barton Moss are all ones where they're trying to drill just a vertical through to measure in detail those different shale layers to see how much is coming through. The other thing that we don't know, it's absolutely critical, is how much gas comes out. So even if there's that gas, how long does that come for? And the reason we don't know that is because the only time we fracked, which was up in near Blackpool, that earthquake paid for that frack. So we didn't get this idea of how quickly it declined off. So we may well, and I was at a Geological conference the other week, they were saying, we may well find that when we get down and we do the detail measurement, there's just not enough gas. Or we may find that actually when we drill, what they call the decline curves are really fast. So in America, you get a lot of gas in the first year you drill, then you get significantly less, and then a lot less, and then within about 5 years, it's back to back. We've got no idea if that's the same decline curve. So people say we might get 10% out. So the shale gas industry said 10%, that's what all the jobs estimates are done. BGS, British Geological Survey, in some places it might be 1 to 3%. So that first figure, that's an economic boom. That second figure, that's not really an economic boom. That's not an industry. So the thing I'm trying to say is there's tons of stuff we don't know. What I think frustrates the scientists, things like, is it what we want to do, or here's me showing my cards, you know, as a scientist, is start getting the data, start getting the information so that we can turn around, because the government's obviously super keen on this, but the scientists aren't. The scientists are holding back and saying, look guys, we don't know if there's enough there to be an industry. At the moment we're stopping it before it's even getting started, and that's because, to a large extent, during the climate change, the Greenland one, this is locking us into more fossil fuels. My argument is the renewables just aren't there yet, and we need to have time to get those renewables up. And shale gas might be the way of moving that forward. And certainly, we don't want to go to Germany and start opening lignite mines, which is brown coal, which is the dirtiest coal you can do. And that trade-off there is certainly something we don't want to do. So I think we need a measured energy strategy, and most of you will have to have things in that energy strategy that you don't like, some of it that you don't like, because not enough of us have energy that we all agree with. So I think there's going to be some of that that's going to help us come.
Iain.
I can sit down now.
Yeah, that's fantastic. So I've got just a few other words of thanks. The first is to Kate and to Rachel. We did all the legwork and the background organisation for this and gave me permission to continue the extension of the question time, which was absolutely brilliant. So thank you very much. To the school, obviously, for making the premises available, to the head for his introduction. I think it's Scott Lees who's been doing a lot of the work in actually making the talk possible, and to all the staff for their help. There is a group of students here who are called the news team. They've been doing the filming, and you're going to be on the web as well afterwards. So well done to them, and thank you very much. And a special thanks actually to Hannah Webb, who was, Hannah's here, who was turning over the slides for Iain at his direction. Obviously, second last group that I want to thank is actually you for coming out and asking these questions. I know there are lots more. We'll have to whisk Iain away very shortly. You might be able to grab him very briefly before that. But finally, I've got to thank Iain himself. And what can one say? Nothing that I can say will do justice to what you have said. It's a brilliant talk, fantastically delivered, incredibly well informed, global in view, local in view, really well balanced. Could we have asked for more? Let's thank Iain again. Action.